All right, so with our metals, it's very easy to tell when things have lost or gained electrons. With our nonmetals, it's a little bit more difficult. But anytime we mess with the bonds in our molecules, we're changing how many electrons these molecules have around them. And there's many different ways to count electrons. One that we're going to learn right now is oxidation states. And again, this is just another way to count electrons. So remember, we counted electrons in multiple different ways. We counted them as like valence electrons. Remember with our octet rule. And what we did here was we double counted electrons in bonds. So for example, this carbon has 8 electrons around it, and this oxygen also has 8 electrons around it. The only way that's true is if you double count those electrons in those bonds. Another way that we learned how to count electrons was with our formal charge. And if you think about what we did in our formal charge, we counted each bond as kind of one electron essentially. And the reason that we did that was because we pretend that these electrons in bonds are split evenly. So for example, if you were to calculate the formal charge of this carbon, you take carbon normally has 4 valence electrons, and then here it has 4 bonds, and then 0 lone pairs, so it has a 0 formal charge. Note that we're counting 4 bonds, but really there's 8 electrons in those bonds, so we're pretending that we're cutting the bond in half, and each atom gets 1 electron of each bond. And then same thing with this oxygen right here. Its formal charge is also 0. Oxygen normally has 6 valence electrons. Here it only has 2 bonds, and again, there's 4 bonds in those, or 4 electrons in those bonds, but we're counting it as they're splitting them evenly. And then 4 lone pairs equals a formal charge of 0. And so the next up is oxidation state. And again, this is just another way to count electrons. So we have our CO bonds here. And now what we're going to do is we're going to pretend that all of the bonds are ionic. And what that means is that the more electronegative atom gets all the electrons in the bonds. So for example, we'll take this, we'll pretend that it's an ionic compound. So this oxygen right here on the left side is going to take all 4 of those electrons in those 2 bonds because it's more electronegative than carbon. And same thing for that other oxygen as well. And then carbon's going to be stuck in the middle with no electrons because it's less electronegative than both of them. And then to calculate the oxidation state, we're going to do the same thing that we did for formal charge, except of course we don't have any bonds. So for example, the oxidation state of this central carbon, oxygen or carbon normally has 4 electrons. Here it doesn't have any lone electrons. And so we have an oxidation state of +4. These oxygens, on the other hand, right, they normally have 6 electrons. Here they have 8 lone electrons, so they have an oxidation state of -2. So what the oxidation state helps us to do is identify where the electrons are at, right? So which one's the correct one, formal charge or oxidation state? Well, neither one of them are correct. They're both just tools, both ways of counting for electrons. The real truth is somewhere in the middle, right? All of these are polar covalent bonds. So the electrons are spending more time around the oxygens than they are the carbons. Of course, real life is more complex. Our electrons are not just discrete particles, but they're actually waves, and they belong to the entire molecule. But oxidation states allow us to identify where we have more or less electron density in a molecule. So this is the formal way to calculate oxidation state. You have to draw out the Lewis structure, break the bonds such that the more electronegative gets all of the atoms or all the electrons. But there's an easier way to do this that works most of the time. That we'll learn next. Again, it works most of the time. every now and then you might have to come back to this idea to calculate the oxidation states.